we shall discuss about preparation of carboxylic acids. These are very simple preparative methods. Okay, there are totally 8 methods. Okay, here oxidation of alcohols gives carboxylic acids. Oxidation of aldehydes and ketones, oxidation of alkyl benzenes gives carboxylic acids. Okay. Other than this, oxidation of the alkenes by Koch reaction and oxidation of the methyl ketones, that is haloform test that we have discussed in that aldehydes ketones part, will give the carboxylic acids. Okay. And here the carbonation of the Grignard reagents give the carboxylic acids, and hydrolysis of the nitriles give amides. Keep in mind that hydrolysis of nitriles give amides. Further hydrolysis of amides give carboxylic acids. Then hydrolysis of acid anhydrides give the carboxylic acids. Hydrolysis of acid halides give carboxylic acid. And finally, the esters on hydrolysis yield carboxylic acids as the products. Okay, let us go one by one. Firstly, we shall consider the oxidation of alcohols. Okay, firstly we shall consider the oxidation of alcohols. Let us discuss with the oxidation of alcohols. Here alcohols, again we have primary alcohol, secondary, tertiary alcohols. Here we are going to discuss about the oxidation of primary alcohols. We know that hydrocarbons on oxidation yield alcohols, alcohols on oxidation yield the carbonyl compounds, aldehydes and ketones, which on oxidation give the carboxylic acid. That sequence I have shown you in the earlier class. Oxidation of hydrocarbons yield alcohols on oxidation yield carbonyl compounds, which on oxidation gives carboxylic acids. Here oxidation of the alcohols sometimes yield the aldehydes or ketones, then give carboxylic acids. Here let us choose the primary alcohols. Oxidation of primary alcohols. Oxidation of primary alcohols. Alcohols require a strong oxidizing agent to convert them to the carboxylic acids. Or else, if you use a mild oxidizing agent, it will fall up to the aldehyde or ketonic part. Okay. Yes. Now, here the oxidation of primary alcohols requires strong oxidants, using strong oxidants like KMNO4, K2Cr2O7, or the chromium trioxide. Okay. Using KMNO4 in acidic, basic or neutral medium is okay to convert the alcohols to carboxylic acids. But when you use these oxidants, we require acidic medium. Okay, acidic medium. Using KMNO4 in acidic, basic or neutral medium, it is okay to convert the alcohols to carboxylic acids. But when you use these dichromate, potassium dichromate and chromium trioxide, will require acidic medium. Okay, let us see one reaction. The oxidation of an alcohol like ethanol, CH3, CH2, OH. What it is? It is called ethanol. Okay, it is a primary alcohol. Okay, in presence of, take this KMNO4, alkaline KMNO4 for example. stands for alkaline in basic medium. Okay, alkaline KMnO4 followed by the hydrolysis. First, you have to treat the ethanol with alkaline KMnO4. You will get a salt, and on hydrolysis, okay, you will get a corresponding carboxylic acid, that is CH3COOH. This is called as acetic acid in common system, and ethanoic acid in IUPAC system. Ethanoic acid. Yes. Similarly, we can convert benzyl alcohol to benzoic acid. Benzyl alcohol. What is this? Benzyl alcohol. Common name is benzyl alcohol. IUPAC name is phenyl methanol. Phenyl methanol. Okay. This when treated with these reagents, okay, that is first we treated with alkaline KMnO4, then followed by hydrolysis, you will get corresponding carboxylic acid, that is benzoic acid. That is benzoic acid. Okay. These examples are not mentioned in the NCERT. Okay. Now, what is the mentioned example in NCERT? That is conversion of decanol to decanoic acid. Conversion of decanol to decanoic acid. Decanol means containing 10 carbon atom alcohol. Okay. Let's take that. CH3, CH2, 9 times OH. Okay. Totally 10 carbons are there. CH2, CH2, CH2. You have to write. Okay. Decanol. What is this? Decanol. When decanol is treated with these reagents, Jones reagent. What is Jones reagent? Chromium trioxide in aqueous sulfuric acid. This is called as Jones reagent. Okay. And here acetone is used as a solvent. Acetone is used as a solvent. For this we are going to call Jones reagent. Okay. And it will be converted to the decanoic acid, CH3, CH2, 8 times COOH. 8, this 9, 10, decanoic acid. Decanoic acid. Here one of the carbon atom is oxidized. Okay. So here one oxygen is introduced here in the place of H2O. OE is attached here and H2 has taken out. Removal of hydrogens or addition of oxygen is called as oxidation. Okay. Here you have to observe oxidation of primary alcohols gives corresponding carboxylic acids. Oxidation of primary alcohols give corresponding carboxylic acid. Whereas the oxidation of secondary alcohol will give a lower member carboxylic acid. That is very important one. Note. What is the note? Oxidation of secondary and even tertiary. Oxidation of secondary or even tertiary alcohol give lower carboxylic acids. Lower carboxylic acids. Okay. And if suppose the unsaturation is present in the alcohol, unsaturated alcohol can be converted to the unsaturated carboxylic acid using Jones reagent. Okay. Yes, this is all about the oxidation of primary alcohols and secondary alcohols. And here, the oxidation of aldehydes and ketones to carboxylic acids is already discussed under the chemical reactions of aldehydes and ketones. So, we shall recall that topic. Even mild oxidizing agents like Tollens reagent, Fellings reagent, Benedict's reagent is sufficient to convert the aldehydes to the corresponding carboxylic acids. Okay. While the oxidation of ketones require strong oxidizing agents like KMnO4, nitric acid, potassium dichromate to convert them to the carboxylic acids. Okay, there you will get lower numbers of carboxylic acids in case of ketones. In case of aldehydes, you will get corresponding carboxylic acids, means retaining the number of carbon atoms. So the second method is oxidation of aldehydes and ketones to carboxylic acids. Oxidation of aldehydes require either strong reagents or even mild oxidizing agents. But oxidation of ketones requires strong oxidizing agents. About these two we have already discussed. Okay, let us go for the third topic, oxidation of alkyl benzenes. The alkyl benzenes can be converted into the benzoic acids using strong oxidizing agents like KMnO4, K2Cr2O7 and chromium trioxide. Here, let us take toluene as an example. Take the toluene, or it is also called as methyl benzene. When it is treated with alkaline KMnO4, alkaline, that is in presence of KOH, okay, and followed by the hydrolysis, what happens if you make this step by step? Okay, you will get first potassium benzoate on hydrolysis, then you will get the benzoic acid. Or else I can show you one after the other. Okay, when toluene is oxidized with alkaline KMnO4, you will get potassium benzoate, that is COOK. This is called as potassium benzoate. Okay, and when this is hydrolyzed, acid hydrolyzed, that is in the presence of an acid, what happens? This K plus ion will be replaced with the H plus ion, and you can see the KOH coming out. Hence, KOH here is used as a catalyst. Okay, then when this salt, potassium benzoate salt, is hydrolyzed with water, you will get benzoic acid as the product. You will get benzoic acid as a product. Okay. Similarly, when you take ethyl benzene or propyl benzene, for example, take CH2, CH2, CH3. This is called as propyl benzene. Okay, here open chain is having only 3 carbon atoms. This is having 6 carbon atoms. And therefore, this is a substituent propyl benzene. Okay, when this is treated with KMnO4 in presence of KOH, that is alkaline KMnO4. Okay. At this part, the oxidation will be taking place at the benzylic part, benzylic carbon. At the benzylic carbon, the oxidation will take place, and you will get potassium benzoate. When this is hydrolyzed, you will get benzoic acid as the product. Okay, benzoic acid as the product. Here the importance is the benzylic carbon will be oxidized. Note, the benzylic carbon undergo oxidation. Yes. This is all about the oxidation of alkyl benzenes to corresponding or lower members of the carboxylic acid, and in this benzylic carbon will undergo the oxidation. Okay. So we shall go for the fourth method, that is from Grignard reagent. Let us discuss about carbonation of Grignard reagent. The Grignard reagent will have the general formula RmGx. Okay. Carbonation is the insertion of the carbon dioxide or carbon monoxide. Okay. Here we are going to treat the Grignard reagent with the carbon dioxide. Okay. Take the carbon dioxide, that is, here we are going to use the dry ice. What is dry ice? Solid form of the carbon dioxide. Okay. Yes. Take the dry ice. C double bond O. Okay. This is the dry ice. Dry ice is nothing but solid carbon dioxide. When this is treated with a Grignard reagent in the presence of ether as the medium or solvent. Ether is a non-reactive solvent. Okay. What happens here? We know this is having two parts. The alkyl part is electron rich and the delta plus, that is magnesium is usually a metal positive charge will be present. Okay. Here, one of the oxygen atom will take the pi bonding electrons. Then the polarity will be created here. It will become O minus. It will become plus. For example, delta minus it will create. Okay. When you take the only carbon dioxide, it is a non-polar one. But when Grignard reagent is added, polarity will be produced here. Polarity will be produced here. So that here one C double bond O will be as it is. This O minus will take up the MgX. Okay, and this R connects to that carbon. So you will get R C double bond O like this. And on hydrolysis, that is addition of water, what happens? O minus will take H plus N from this. Okay, it will become C double bond O R OH. Okay, plus MgOH X. Okay. Yes. What is this? RCOOH. It is nothing but general formula of the carboxylic acids. Okay. Carboxylic acid. Okay. Let us take some example. If R is CH3 group, okay, then what would be the carboxylic acid? CH3COH, that is acetic acid. If this is a phenyl group, then benzoic acid will be the compound. I will show you that. Take the Grignard reagent and carbon dioxide. For example, it is CH3, MgBr. In presence of ether, it will form CH3, C double bond OMgBr. On hydrolysis, you will get CH3COOH as the product. Okay, what is this? Acetic acid. Acetic acid is the product. Okay, and similarly, when you take dry ice, treat this with C6H5 or benzene. You may have benzene or C6H5. Okay, what happens? This takes place in the presence of ether as the medium. Similarly, you will have a benzene ring. Then, imagine it is a benzene ring connected to the carbon, carrying double bond O. Then O MgBr. Okay. When it is hydrolyzed, you will get OH here. So therefore, it will be benzoic acid. It will be benzoic acid. Okay. What will be the byproduct? MgOHBr will be the byproduct. MgOHBr. It will be the byproduct. So this is the way of converting the Grignard reagent to the carboxylic acid by carbonation, that is addition of carbon dioxide or carbon monoxide. This is very very important, asked it several times in the annual examination also. Okay, let us discuss about the hydrolysis of nitriles or cyanides to amides and further hydrolysis of amides to carboxylic acids. Yes, let's consider general example here. RC triple bond N, it is called as alkyl cyanide or alkyl nitriles. Okay, you may take aryl also, no problem. Here, this is the cyanide. Where R is alkyl or aryl group. Alkyl or aryl group. When this cyanide is hydrolyzed in the presence of an acid or basic medium, it is hydrolyzed in presence of an acidic means H plus N, or basic medium, that is represented with the OH minus ion. When cyanide or nitrile is hydrolyzed in the presence of an acidic or basic medium, gives amide as the product. Gives amide CONH2. Gives amide as the product. Further hydrolysis of this in the basic or acidic medium, okay, will give the carboxylic acids. If you add H2O, it is like adding H plus and OH minus ions. That OH will join here, NH2 minus will join with the H plus ion. So therefore, the byproduct is ammonia, the product is RCOOH, that is called as carboxylic acid. That is called as carboxylic acid. Okay, RCO will join with OH. This NH2 will join with H plus N, so it will become ammonia as the byproduct. Okay, let's take corresponding. Let us replace this R with alkyl or aryl group. Okay, for example, take CH3CN. This is called as ethyl. This is called as a methyl cyanide. This is called as methyl cyanide or ethane nitrile or ethane nitrile. Look at the difference between the common name and IUPAC name. Methyl cyanide, C of cyanide is included. Ethane, 2 carbon atoms, nitrile for triple bond. This you have to notice properly. Okay, when it is hydrolyzed in presence of acidic or basic medium, you will get corresponding amide, that is CH3CONH2. Its common name is acetamide. Its common name is acetamide. IUPAC name is ethanamide. IUPAC name is ethanamide. These are very very important. For 2 carbon atoms here I am going to call acid, and for 2 carbon atoms in the IUPAC system it is eth. Okay, and when it is further hydrolyzed in the basic or acidic medium, you will get corresponding carboxylic acid CH3 C double bond OH. This is called as acetic acid or ethanoic acid. In the IUPAC system it is called as ethanoic acid, and the byproduct is ammonia. Okay, yes. If you take the R as aryl group, for example benzene, this is called as benzene nitrile. This is called as benzene nitrile when it is hydrolyzed in the presence of acidic or basic medium. You will get benzamide as the product. Further hydrolysis of this benzamide will give corresponding carboxylic acid, that is benzoic acid. Benzoic acid. So this is all about the conversion of nitriles to amides to carboxylic acids by hydrolysis in the presence of an acid or base as a catalyst. Okay. Now let us discuss about the hydrolysis of acid anhydrides. Look at the word anhydride, that is absence of H2O. When the 2 moles of carboxylic acids are heated, it condenses to give the anhydride with loss of water molecule. When that anhydride is again hydrolyzed, give back the original carboxylic acids. Okay, let us see that. Take the acetic anhydride, CH3, C double bond O, C double bond O, CH3. This is called as acetic anhydride. Acetic anhydride. When you add water to this, okay, what happens? Here, for example, imagine here bond breaks. H plus, what is nothing but an addendum having positive part and negative part. Okay. O minus will join the H plus and will become CH3COOH. CH3CO, O minus will join with this H plus. And this CH3CO plus will join with OH minus and becomes CH3COOH is the product. So, hydrolysis of acetic anhydride will give you 2 moles of acetic acid. Will give you 2 moles of acetic acid. Okay. When 2 moles of acetic acid is treated with acid or heated, when it is treated with an acid or heated, gives back the original acetic anhydride. Acetic anhydride as the product. Acetic anhydride as the product with the release of water molecule. This is called as condensation. Okay, or dehydration of acetic acid will give the acetic anhydride. This is from here to here it is preparation of carboxylic acid, and from here to here it is chemical property of carboxylic acid. Okay, that I told you earlier, in organic chemistry we can convert any compound to any compound. Okay, that is possible. Okay, and for preparation up to here is enough for us. There is extra, this is extra point, this is extra point. We can convert the anhydride to carboxylic acid to anhydride, that I have shown there. Okay, yes. If you take benzoic anhydride, C6H5, C double bond O, C double bond O, C6H5. This is called as benzoic anhydride. Benzoic anhydride, when hydrolyzed, okay, use the benzoic acid. For example, here the bond breaks, H plus N will join this, will give benzoic acid. And OH minus will join this, will give one more benzoic acid. Okay, here we are getting 2 moles of benzoic acid. Okay, and anhydride, 1 mole of anhydride will give 2 moles of carboxylic acid on hydrolysis. This you need to remember. Okay. The 7th one is conversion of acid halides to carboxylic acid again on hydrolysis. Okay, let us take an example. RCOCl, where R may be alkyl or aryl group. Okay, what is this? Acid chloride. The direct addition of H2O will be slow reaction. Will give corresponding carboxylic acid plus HCl as the product. Okay, we can catalyze this reaction to faster by addition of a base. Okay, that is base catalyzed hydrolysis. Base catalyzed hydrolysis. You have to take a base like NaOH or KOH. Okay, base catalyzed hydrolysis. Take RCOCl. Okay, treat with a base like sodium hydroxide. This reaction will be fast. Okay, when you direct add water to the acidic chloride, it will be a slow reaction. When you add this NaOH, this will be a fast reaction, and here you will get RCOONA. Okay, I will write this fast here. This reaction will be fast, and the byproduct will be HCl. Okay, this ONA joins here. Okay, like this. Cl minus comes out, join with H plus N, and the byproduct is HCl. Okay. When this is treated with an acid that is acid hydrolysis, will give you carboxylic acid. This is called as sodium carboxylate or sodium salt of carboxylic acid. Sodium carboxylate. This is what carboxylic acid. And byproduct will be NaOH. See, this is a base catalyzed reaction. You are using base as a catalyst. What is the definition of catalyst? Catalyst is a chemical substance which increases the speed of the reaction, but it is not consumed in the reaction. It increases the speed of the reaction, but it is not consumed and will be coming as it is at the end of the reaction. Okay, here you may take R as the alkyl group or aryl group. Okay, yes, you need to practice that. The next topic is hydrolysis of esters to the carboxylic acids. I will give you a general reaction here. The hydrolysis of ester, simple direct hydrolysis, will be slow. I will show you that. This is the general representation of the ester. Okay, where R and R dash may be alkyl or aryl groups. Where R and R dash may be alkyl or aryl groups. When we do simple hydrolysis, this will be a slow reaction. Okay, will give you the RCOOH plus R dash OH. You are going to get two compounds. Where the bond will break? Here the bond will break. Carboxylate ion will be on one side. Alkyl cation will be on one side. Okay, this is a carboxylic acid and this is an alcohol. Okay, can be increased by adding an acid or base. Okay, we can increase the speed of a reaction by acid or base hydrolysis. Okay, let us consider base catalyzed hydration. How? Take that R, C double bond O or R dash. Treat this with NaOH. This reaction will be fast. Okay, you will get RCOONA, and the remaining will be, you will get RCOONA, and this is going to join here since it is negative. Okay, R dash will join with this, R dash will join with the hydroxyl group and give you the alcohol. Okay, this is called as sodium salt of carboxylic acid or sodium carboxylate. Sodium carboxylate. When this one is hydrolyzed, okay, you will get RCOOH plus NaOH. Okay, this is what? Carboxylic acid. NaOH is introduced here and it is exited in this at the end of the reaction. Therefore, a base is used as a catalyst. Okay, so this is all about base catalyzed hydration. Here you may take R, maybe R and R dash will be alkyl or aryl group, and you need to practice that. I will show you one example. Okay, I will show you one example. Take an ethyl benzoate. Take ethyl benzoate. Okay, this is ethyl benzoate. When this is heated with NaOH, reaction will be fast. You will get sodium benzoate plus ethyl alcohol. What is this? Sodium benzoate, and what is this? Ethanol or ethyl alcohol. Where the bond has been broken? At this part. Okay, bond breaks at this part. This carboxyl part will be at one end. Okay, and this on hydrolysis will give the benzoic acid as the compound, plus here H plus N will join and Na will take OH minus of the water. Okay, what is this? Benzoic acid. Here NaOH is acting as a catalyst. Base catalyzed hydration of ester is fast. Okay, yes, this is all about the conversion of the esters to the carboxylic acids. Okay, we have discussed the conversion of alcohols, alkyl benzenes, aldehydes and ketones to the carboxylic acid on oxidation, and conversion of the Grignard reagent to the carboxylic acid by carbonation, and conversion of the acid anhydrides, acid halides and esters, nitriles and amides to the carboxylic acids upon hydrolysis. Okay, so this is all about the preparation of carboxylic acids. Now we shall discuss some of the physical properties of carboxylic acids. Usually we shall discuss with the four properties. One is physical state, odor, boiling point and the solubility. Okay. Here, when it comes to the physical property, the formic acids the carboxylic acids are polar and will undergo association together, whose boiling point is also high when compared to the other class of organic compounds. That is why these will start from liquid state. For example, when you take the simple carboxylic acid, that is a formic acid containing one carbon, that is also a liquid at room temperature. These are liquids from C1 to C9. Liquids at room temperature. At room temperature. Okay. And after 9 carbon atoms, these will be wax-like solids. C10 and above. Wax-like solids. Wax-like solids at room temperature. Okay. The carboxylic acids, due to association of the molecules, these will start from liquid at room temperature. Then these will be wax-like solids. Okay. Come to the odor. The lower members have unpleasant smell. Unpleasant smell or pungent smell. And higher members are less pungent. Higher members are wax-like solids, no, and those are not volatile and don't give smell also. Okay. Very low pungent or no smell, sometimes no smell. Okay, this is about the odor. Come to the boiling point. These carboxylic acids, when you make the carboxylic acids, this is the structure, and take one more carboxylic acid like this. C double bond O H. See, when two carboxylic acid molecules are together, both are polar, and here the intermolecular hydrogen bonding exists. This is what? Intermolecular hydrogen bonding. Okay. And the presence of strong intermolecular hydrogen bonding between the carboxylic acid molecules makes it as a dimer. Even in gaseous phase, that is upon heating also, this will make intermolecular hydrogen bonding in the vapor state, gaseous phase. Okay. And whose boiling point is high due to the association of molecules. Due to the association of molecules through intermolecular hydrogen bonding results in high BP. The higher boiling points of carboxylic acids is due to the association of molecules through intermolecular hydrogen bonding leads to high boiling points. Okay. Now order of BP. Order of BP is like this: carboxylic acids. Okay. After this, alcohols. After this, aldehydes. Then ketones. Then corresponding ethers. Then hydrocarbons. Here, the force of attraction in hydrocarbon is less, so therefore it will have low BP. The force of attraction is high in carboxylic acid due to association of the molecules and intermolecular hydrogen bonding, so it will have high BP. Okay, this is the correct order of the boiling points. In the corresponding molecules, means these, when you take the corresponding compounds, that is with the same number of carbon atoms, this carboxylic acid will have high pp, the hydrocarbon will have low pp out of all this class of compounds. Come to the solubility. See, organic compounds are carboxylic acids. Carboxylic acids are what? Carboxylic acids are organic. Carboxylic acids are soluble in organic solvents like alcohols, ethers, benzene, chloroform, etc. Because these are organic. Keep in mind that organic is readily soluble in organic because of the covalent nature. Same similar forces of attraction. Carboxylic acids are soluble in alcohols, ethers, benzenes because these are organic. Okay, and the solubility of carboxylic acids. Lower member of carboxylic acids are lower members of carboxylic acids. Lower members of carboxylic acids are soluble in water. Are soluble in water due to their polarity and able to make hydrogen bonding with water hydrogen bonding with water. Okay. As the number of carbon atoms in the chain increases, polarity decreases, ability to make hydrogen bonding decreases, hence become less soluble and insoluble in water. Okay, let us take a general one. C double bond O H. Let us see how it is going to soluble in water. Take H2O. This is a polar one, delta plus, delta minus. This is a polar one, delta minus. This is delta plus. Okay, these will make the hydrogen bondings like this. Okay, this is hydrogen bonding between the carboxylic acid and the water. This property makes the solubility of the carboxylic acids in water. Okay, when this alkyl part, that is the number of carbon atoms in the alkyl part, that is when we move from methyl, ethyl, propyl, butyl, pentyl, like that, polarity of this group decreases and ability to make the hydrogen bonding with water also decreases. Then the higher numbers of the carboxylic acids are insoluble in water. Okay, so this is all about the physical properties of the carboxylic acids. In the next class we shall discuss about the chemical properties of carboxylic acids. Thank you.